In this video, I want to just quickly describe the time complexity of matrix operations in the Big O notation. So if you don't remember Big O notation, or if you have forgotten it, or maybe even never learned it, then I linked to another video on this page that kind of goes over it briefly. So you may want to review that before watching this. But here are the two operations I want to talk about. So I want to talk about matrix addition. And when we do matrix addition, right, remember what we're doing. I'm just going to kind of draw a schematic of it. If we're adding two matrices, then they both have to be the same size. So maybe n rows and m columns, right? They both have n rows and m columns. And then the resultant matrix is also n rows and m columns. And for every single entry, to get that entry in the resultant matrix, you're going to have to do exactly one addition. So altogether, there will be n times m additions. Now, time complexity for matrix operations is generally characterized in terms of square matrices. So we'd say matrix operation is a big O of n squared task. And of course, matrix multiplication is more complicated. So let's just think out a schematic if we're multiplying two matrices. So we know if we're going to multiply two matrices, the number of columns of the first matrix has to match the number of rows of the second matrix. So this might be an n by m matrix, and that would mean that this matrix that you're multiplying it by would have to have m rows, and then it could have some number of columns. And the resultant matrix is going to have n by k dimension. And now for every single entry, there are n times k entries. So for every single one of those entries, we're going to have to carry out this operation where we take the entries in the first matrix, we take a row of entries in the first matrix and a corresponding column of entries in the second matrix, and then we multiply and add along those, right? So how many multiplications are we going to do? Well, there are m numbers in this row, there are m numbers in this column, so we're going to have to, multiply entry-wise, and we'll have to do m multiplications, and that's for just this one entry over here, right? So altogether, we're going to have m times n times k, right? Because we're doing those m multiplications n times k times. And again, usually these time complexity characterizations are given for square matrices. So if m and n and k, m and n and k are all equal, we'd say, right, usually that this is big O of n cubed. And if you remember anything about computational time complexity, n cubed is terrible. So anytime we have an opportunity to take advantage of some special structure in our matrix, we'll want to do that because matrix multiplication is computationally expensive. Okay, that's all I had to say.